the rod is given angular velocity and released it from this horizontal position. Then immediately what happened? We should okay. There's a question. So let me show all the things here. So what are the forces that are acting? The weight mg, the weight of the rod mg. Then any other forces are acting. Centrifugal force. Why centrifugal force? And defining the motion with respect to that one. And there'll be reaction. Ry. The centrifugal force will try to move the rod radially outward. So here the reaction Rx, and it will have angular acceleration alpha and acceleration of center of mass. Okay, this is O, this is AC. So write down the equation again. Mg into L by 2 equal to IO alpha. Same thing like previous problem what we did, similar way. So what is alpha naught equal to 3G by 2L. Then after getting this, I want acceleration of center. Don't write AC, sir, weight mg is acting, then acceleration of center equal to g. No, you write down the equation. First, what is rotational motion? Say what type of motion the rod will describe? Only rotational motion. No? Then AC should be equal to L by 2 alpha naught. No, let's write the equation. Mg minus Ry equal to MAC. I think nothing changed. It is just previous problem only. Only Rx has come into picture. Now what about Rx? Rx, you're going to write it as M omega naught square L by 2. Total reaction. What you should call this? Reaction at the inch. You have to ask me this question. You have to ask this particular thing. I'm shading it. Why you are writing this equation, sir? Why don't you take why don't you describe the motion of any other point and write some equation? So this is some sort of translatory motion. So this is rotating motion. I'm shading it. This is what equations due to rotating motion. No? And what about this? This is some sort of like a translatory motion. So, but rod is not rotating at that instant. The rod, what happened? Rod don't know whether Ry will act or not. No, the rod wants to move vertically down. Then the reaction Ry will come into picture. Sir, now you have to ask me question. Sir, is it rotating or translative motion? It's only rotative motion. For center of mass open, we are just, the center of mass will feel as if it wants to move vertically down, but the hinge will not allow. See, the moment you release, the rod what happened wants to move vertically down. The hinge what happened will exert a force. So therefore, the moment this equation for all the position are only at that instant. So at that instant, mg minus ry equal to mac. So this you will get confused. So therefore, I'll remove it. So now what happened? So when you're describing the translative motion, you should take help of center of mass only, not about any other point. So this will get confused. So I'll just take it out. So just I said it, I'll take it out. Okay, clear this. So you should not define acceleration of any other point. So why don't we define acceleration of this point? Yes, you can find out. So what is the acceleration of point A? Should be equal to L alpha plus AC. If center of mass moves, then all points should also have acceleration. Is it like that? No. What is acceleration of point A? Acceleration of point A is only L alpha. No, don't write L alpha plus A, that one. Because it's having only pure rotational motion. So what we have to write? Rod describes only rotating motion. Is the fixed axis rotation. Finish over. is a fixed axis rotation. Let's come. Okay, now I brought it. Why only rod? Let's take other plates, semicircular plate. Now immediately first come to the where the center of mass of semicircular plate will be.